Good afternoon, Year 5, and welcome to your second science lesson of the week. And it is another noisy science lesson. If you have got access to plastic straws and a pair of scissors that you can use safely, then you will need that for today's experiment. So let's first of all have a look and see what we are doing today. Let's start off with our three starter questions. What does it mean if a material conducts heat? Think about what the word conductor means, not in the sense of someone at the front of an orchestra. From previous learning, why does the sun appear to move across the sky? That word appear is really important there. And from our last lesson, how do guitar strings make different pitches? If you're on Teams, then go through to the document to fill that in. If you're not on Teams, then have a go at answering those. But please make sure that you're getting yourself on Teams as soon as possible. Okay, let's have a look at our answers there. So if a material conducts heat, it means that heat can travel through it. The same with conductors of electricity. Why does the sun appear to move across the sky? It's because the Earth is rotating, is spinning. So as the Earth spins, it makes it look as though the sun is moving across the sky. But compared to the Earth, the sun is stationary. And how do guitar strings make different pitches? They are different widths, different thicknesses, and different tautness, so they're stretched in different ways. So today we are looking at the same key vocabulary. So we're still looking at pitch, but instead of being in string instruments with the elastic bands, we're looking at in woodwind instruments. So where we are blowing into things. So the source is the sound, the object that a sound comes from. If something's vibrating, it means it's moving continually and rapidly to and fro. Vibration is an instance of vibrating. Pitch is the quality of a sound referred to by whether it is high or low, and sound waves are a visual representation of the pitch of a sound. Here are your scientifically working skills. If you've got something that happens to measure hertz at home, then you're more than welcome to use it. I haven't explored apps to see if there is an app that does that for our experiment, but we're just going to be using comparisons instead. So when we're comparing this, we're looking at whether it starts off high or low and gets higher or lower. So it's absolutely fine if you don't have something that measures hertz, because I certainly don't. So a bit of a reminder from yesterday on what pitch is. So pitch means how high or low a sound is. Pitch is measured in something called hertz, and the higher the hertz, the higher pitch the sound. Humans can hear a range between 20 and 20,000 pitch hertz, sorry, but that decreases as we get older. So you will find that sometimes they can play sounds on TV that younger people can hear that older people can't. There is an amazing, very strange system of trying to stop young people from meeting up in places where they play a really high pitched noise that adults walking past can't hear, but it annoys teenagers, so they end up not staying in that area. And that's an example of how that can be used, or how it is used. Whether it should be used like that is another matter. Um, we talked yesterday about how animals have got a different range of hearing to humans. So dogs and bats can hear much higher sounds than humans, and elephants can actually hear and feel much lower sounds than humans. Here's some examples of some sound waves showing a high pitch and a low pitch. So to make a high pitch sound, it needs to vibrate quicker than normal. That's why when the strings were tighter yesterday, they were vibrating more quickly, which created a higher pitch. So for today's experiment, you will need a plastic straw, some scissors, and possibly a ruler if you've got one. So if you've got a plastic straw like this, it's got a bendy bit on it. Let me come out of this. Oh, sorry. If you don't have these bits and pieces, don't worry. I'm going to attach a video again so that you can observe something and you can still do a write-up of your experiment as if you had done it. This won't work with paper straws either. I don't think the plastic straws are a little harder to get hold of now, but if you can, then that's brilliant. So what I need to do first of all is I need to cut off the bendy bits. I don't need that. And then I need to flatten one end of the straw. So I'll squeeze that down. Once I've flattened it, I need to cut a V shape into the end of the straw to make something called a reed. Now, this is something that all instruments that you blow into have got. So I should end up with, where's my camera? Something that ends up looking like this. Now, it's not very flat at the moment, so I'll have to flatten it down a bit. And here is one earlier that shows you how flat it is. Now, if I put it up to my mouth now, I get that rather exciting noise. I'm just going to move my microphone a bit so that you can hear it better. Doesn't always work for me. So that is our straw. It's like an instrument called a kazoo. But there's something rather cool that you can do with this. I'm going to do it very quickly, but what I'd like you to do is you can do it really quickly if you've got more than one straw. But if you've got one straw, then measure the length of the straw, blow into it, and then write down what pitch it makes. Is it a high pitch or a low pitch? And then cut a bit off, measure it again, and then see what the pitch is and see how it changes it. Because if you were to do it quickly, which if you've got enough straws, you can do it like this, and it should sound like this. There you go. So you can hear that as you have lost bits of straw all over my table now, you can hear that as the length of the straw changes, the pitch of the sound changes. So your job today with your experiment is to explore what that relationship is. What happens as the kazoo is longer? What happens as the kazoo is shorter to the pitch of the sound? Just like yesterday, I've put up a couple of bits on Teams that you can use to write up your experiment. So have a go with that. Please do wait until there is a moment because they are louder than you expect them to be. But enjoy it. It's quite fun.